Okay, so I wanted to, just kind of talk about some of the most missed questions um, on the quiz you took this weekend, and I'll highlight a few that I thought were really good, and things that you should be reminded of, things that a lot of students had missed. And one of the first ones was question number 3, part A, where it says find the value of the integral from 4 to 8 of f of x, or explain it does not exist. And definitely an intentional, purposeful question where there are, 2 points of discontinuity. A lot of you recognize that right away, that, like I forget what the values are. Oh yeah, at x equals 5 and x equals 7, f of x is not continuous. And so a lot of you had mentioned that, it's not possible to find that integral because of the discontinuities. And the thing is that finding area, when you're finding this definite integral, you don't have to be a continuous function to find definite area. And in fact, I wrote a couple of comments about thinking about some of our improper integrals who have boundaries at infinity, or who have a vertical asymptote as a boundary. So those are other representatives of discontinuities that area could also exist. And so the rule of thumb is, as long as it's defined for every point on that interval, you can find that area. So from 4 to 8, everything is defined, even though there's this jump discontinuity and a hole here that's jumped up there. It's still, you could find a finite area in terms of finding out the displacement under the curve. So be careful of that. It doesn't have to be continuous for the integral to exist, but it does have to be defined in that interval. And then when you look at endpoints, obviously endpoints, you would have to evaluate them separately. Like I'm thinking about improper integrals and things like that. So careful on that one. Okay. Next question that a lot of students missed was, this was when you're analyzing that logistical differential equation and you're trying to find a second degree Taylor polynomial. And remember our, just our generic second degree Taylor polynomial formula. Remember, so our second degree Taylor polynomial, it's centered at 0, so really technically it's a Maclaurin polynomial. So it's like we're looking for f of 0 plus the derivative at 0 times x the first power over 1 factorial plus the second derivative of 0, x squared 2 factorial. Okay, and I think oh yeah, right, so it does tell us that f of 0 is 8. Great, so we can fill that in. So we have an 8 plus, and then to find the derivative of at 0, remember that this differential equation here is a derivative with respect to y. So I know that when x is 0, my y value is 8. So I actually can figure out what is the derivative when y is equal to 8. Oops, y is equal to 8. So then that would be 8 over 8 times 6 minus 8, which is 1 times negative 2, which is negative 2. So I know that that coefficient is a negative 2x over 1. And a lot of people had up to that point. But where we maybe made a mistake was that second derivative, because the second derivative of at 0, all I have is this formula here. So that means I have to take its derivative. And the thing is, it's implicit because this is in terms of y. So every time you take a derivative, immediately must multiply by dy dx, or exactly, because or dy dt in this case. Okay, so what I did then is I I distributed that y over 8. So I made dy dt is equal to 6 over 8, so 3/4 y minus 1/8 y squared. I just thought that was easier than having to do the product rule. And then when I do the derivative, so the second derivative of y with respect to t twice, so this is not t, so I can take its derivative 3/4, but then immediately multiply by dy dt. Minus, and then this becomes 1/4 y, but then immediately multiply again by dy dt. And then remember, dy dt was our expression up here. So then I had to remember that, so like dy dt when y was equal to 8 was equal to negative 2. So then I know that this is 3/4 And then this is specifically at that point where we just found it up here. So then I know it's a -2 minus 1/4 times 8, that's our same y value, times another -2, again, dy dt. So that's -6/4, which is -3/2. And this becomes ultimately a positive. And then 1/4 of 8 is 2, and then 2 times -2 is 4. So we end up getting -3/2 plus 4, which is 5/2, or 2.5. So that was the coefficient that we were looking for. So that's your f double prime of 0, and that's where a lot of people made a mistake. X squared divided by 2 factorial, which is 2. So then that coefficient, I wrote that in a lot of people's papers, that coefficient should be 8 minus 2x plus 5/4 x squared. And it is a polynomial, so please make sure it's like a p equals t equals whatever. And then you're using that to approximate 1. Well, if you didn't have the right function, you would have obviously gotten the 1 wrong. But when you plug in 1, f of 1 approximately equals 7.25. So really, really, I guess, tricky question because you had to remember to do implicit differentiation. Okay, now this problem here, part A, was a very, very common missed question. We're trying to find R, and maybe it was a little deceptive, but I took this right from the AP exam, but R is really, this region here that's in between those two curves. So it does lie in quadrants 1 and 2. Now, I don't know if some people maybe just thought it was just to the left or just to the right, but there's R. We have to find these 2 points of intersection. And this point, actually, you could even find by inspection, by setting the two equations equal to each other. That happens when x is 1. Both of their y values equal 2. So this point here is 1, 2. So that's an easy one. This point here is a little bit tougher. Use your calculator, find its intersection. And so I did that, and I just called that point A right here. And so when I was integrating this, I knew that I didn't want to have to keep rewriting this A over and over and over again. So I calculated it, stored it in my calculator, and I said A was this -1.6365, kept all the digits. So we're looking at this region here, and we want to rotate that around the vertical line x equals 2, which I have in my work right here. So, I just drew its mirror image over here. And as I'm rotating this, I realized that if I tried to make this like a washer method or a disk method, and that would have meant that my radii would have been like perpendicular to that line of rotation. The problem is that up here, I'm bound between the same curve, and so therefore I would get like an area of 0, which doesn't make any sense. And so then I have to kind of finagle that, and I didn't like that at all. So I did it in terms of a vertical direction. So now I'm still in terms of x because I'm perpendicular to the x-axis, but notice that these become cylinders. And so I have to realize that how do you find the volume basically a volume of a bunch of cylinders. Remember, cylinders is 2 pi RH, that in terms of finding its volume. And then we're just going to have an infinite number of those. And so the height, the height of these, there it is. Oh, one more time. The height, let's try this one. Where's my pen at? Oh, there it is. Okay. So the height, there we go, would be the distance, sorry about that, between the two functions. So top minus bottom. So that is represented here. So the top function is a quadratic. The bottom function is our exponential. Now, the radius here, it's 2 minus x, because if you think about this is your line of rotation, and you need to figure out what is this distance right here? So you are 2, but then you are taking away whatever your value was here, like whatever x value you're at. So I really need this radius here. So it's 2 minus x. And that accounts for if you are on the negative side, you're actually further away. So that negative x becomes a plus x. So there's your radius, there's your height, there's your 2 pi from your smallest a value to your highest a value of 2. Again, a lot of students maybe missed that problem, so I just want to double check that one. And so then I think this is the last most common missed one, was part C of this 3-part question. Here's a table of values, and I could easily see this coming up on the AP exam, since you have calculators and notes and defined well-known Taylor polynomials. They probably are going to make you create something from a table. And so here it is, and there's the values at 2 particular points at 0 and 1, and it says we want to construct a 5th degree Taylor polynomial for the derivative of g, centered at 0. So I definitely know I'm using this line right here. And it says, oh, well, look, g is equal to f of x cubed. And in part A, you actually had to find the Taylor polynomial of f of x centered at 0. So like this was my answer at part A. This is the Taylor polynomial centered at 0. And so then if I want to just do a change of variable, like basically substituting x and make it x cubed, so then my initial point, here it is. So then my initial point, there we go, would be the substituting wherever there was an x with x cubed. And since it's still centered at 0, don't worry about anything else. And so then that becomes 4 plus 5x cubed minus 1/2 x to the 6th, and then take its derivative. So then that was the answer. So I'm anticipating multiple parts of the AP exam, and this is a great example of doing that. Generating a Taylor polynomial, integrating it, differentiating it, rewriting it in terms of another variable. So just be very careful and kind of heads up on a question like that. I think that was it in terms of the questions that were the most missed. There's a couple comments here and there, so I'll definitely look through them because I want to make sure you guys are as prepared and successful for the exam as possible. If there's anything else on that particular quiz, just definitely shoot me an email, pop in office hours. It's simply by making sure all your questions answered.